Have you ever hunted before? Rabbits or foxes? Have you ever wondered why sometimes there's an abundance in foxes, so you get a bunch of easy kills, while other times it seems as if foxes have gone extinct? What about rabbits? One day you got a full pot of rabbit stew cooking for dinner, and the next, your whole family's mad at you because you didn't bring home the meat. Well, I've got good news for you. Me, working with a real-life hunter, we've investigated how the populations of rabbits and foxes relate. We've considered several factors, including the food supply of rabbits, the carrying capacity of each animal, the number of times the animals have come in contact with each other, and several others. I'm going to pass it on to Hunter to explain some of our findings.
Yeah. Hi, I'm Hunter, professional rabbit hunter. I'm going to show you some of our calculations that we've done for this investigation. So, our rabbit population in our equations is represented by R and fox population by F, respectively. We decided the units of time we would consider as days. Based off of our initial conditions given, we made differential equations that describe the rate of change of the populations of rabbits and foxes. So the rabbits population changes with respect to time by a proportionality constant of 0.05, but then every instance a rabbit comes in contact with a fox, that takes away this amount of rabbits and foxes with a proportionality constant of 0.001. And we used a similar method with the fox population. Using Euler's method, we used Excel to put these differential equations into Euler's method, put this equation into Excel, and made a graph that represents the populations of rabbits and foxes over time using different values for our delta t. And Tyler will now explain the graphs.
Thanks, Hunter. All right, now to explain the graphs. As you can see, it kind of looks like a beach with some sand and some waves, or it looks like two snakes slithering, or like a mountain maybe.
Whoa. Hey, whoa. Let me explain. Obviously, you don't understand what these graphs mean. So, as you can see, these graphs are sinusoidal. They're related to each other. So, the graph on the bottom represents the fox population, and the graph on the top represents the rabbit population. As you can see, when the fox population is the highest, that is when the rabbit population is decreasing at the fastest rate. Similarly, when the rabbit population is the highest, that's when the fox population is increasing at the highest rate. So this makes sense intuitively because when there's more rabbits, there's going to be able for more foxes to be born and they'll have more food to eat. As with when there's more foxes, they're going to be eating the rabbits the fastest, which is why the rabbits population is decreasing.
Thanks for the help, Hunter. Now we're going to cut to a press conference where we answer your questions about the investigation as the entire world eagerly awaits the release of our findings. Welcome to the press conference. We'll now open the room to questions about our investigation. Me! Did you take in consideration of the food supply for rabbits in the area?
As a matter of fact, we did. So, we know from science that the food supply for rabbits is limited, and when there are no foxes present, the rabbit population will grow at a rate jointly proportional to their population size and the difference between the carrying capacity and their population size. This is the proportionality constant, this is the rabbit's population size, and this is the difference between the carrying capacity and the rabbit's population size. We also have to take in consideration every contact between a rabbit and a fox will decrease the population. But this produced a similar graph to the previous differential equations. Thank you for your question.
I have another question.
You over there.
Have you considered what happens when the initial populations of the foxes or rabbits are different?
As a matter of fact, we have, sir. This here represents the graph where the initial rabbit population is 100 and the initial fox population is 80. So this is less rabbits and more foxes. As you can see, the graph obviously looks different, but you still have the same relationship between rabbits and foxes where the fox population is the highest is the same moment as the where the rabbit population is decreasing the fastest, and where the rabbit population is the greatest, the fox population is increasing at the greatest amount. So you still have the same relationships between the populations, even though the graph might not look the exact same. In the long run, they will look very similar.
Thank you for attending our press conference. If you'd like to know the optimal conditions for hunting rabbits or foxes, buy our publication.